All of you?
Force and laws of motion.
Yeah, actually our chapter name is dynamics. In that, the concept which we are studying is
Laws of motion.
force and laws of motion. So if you notice it, in this we are studying actually a three laws. Newton's first law. Actually, this is not force and laws of motion. Force and Newton's laws of motion. That is even more perfect. So Newton's first law, Newton's second law, and as well as Newton's third law. So now Newton has formulated these laws. Actually, you know one thing, guys, whatever the things, Newton forms universal law of gravitation. Next chapter, gravitation we studied. Universal law of gravitation. Newton forms Newton's first law, Newton's second law, Newton's third law to describe about motion of a body. So whatever it is, if you notice it, it is not actually done by him alone. He actually inspired the work by somebody or copied the things from somebody and he made the laws. Do you understand, all of you? So everything, there is universal law of gravitation, one of the most popular law of Mr. Newton's, but it is copied from Kepler's laws. It is copied from Kepler's laws. Kepler is the one who has been actually worked on it, and he has been formulated the laws from him. Like that, Mr. Newton has been formed the Newton's first law. Of course, we will study what is Newton's first law. It is not actually done by him completely. He has been inspired the work of somebody's, and then from that he formed the laws. So that is only he inspired to form the Newton's first law. He inspired the work of Mr. Galileo. So Galileo's observation, he has done some experiment. Mr. Galileo has done some experiment. From that only Mr. Newton has been formed the law. That is what Newton's laws of motion. So all of you keep reading. So the inspirations to the Mr. Newton to form the Newton's laws of motion, the main thing is observation of Galileo's. So observations of Galileo or Galileo, whomever it is. So from his work only he has been actually inspired by him. Yeah, GALI, not LLI. So GALILEO, Galileo. Okay, guys. So let's start now. What is his observation, everybody? And what Mr. Galileo has done. Okay. So now if you have noticed it, everybody carefully, Mr. Galileo has been conducted some experiment. Even you can notice in our textbook, it is there in our class 9th textbook also. So chapter 8. So there is a two inclined surfaces has been kept. You can notice in our textbook. Is there or not? Verify, everybody. Is it there? All of you? Two inclined surfaces, a ball is dropped from one ramp and it is passing to another side. Have you checked it, everybody? Anybody can tell me? I don't have a book. I have old book. You can notice it. Chapter number 8. All of you? Yes? So I will show you the picture. Similar picture, you can see that. Can you see it like this picture in our book? But this is slightly different. It will be a little bit more informative, but that book is like a realistic inclined surfaces. Can you tell the page number, Mr. Mari, so that everybody can see it?
89.
89. So please all of you open that page number. Mr. Lingesh, good morning. So can you see that, everybody? All of you?
Yes, sir.
So observe that actually the scientist who actually demonstrated the relationship between motion and the force, who actually, it is Galileo. It's not the Newton. Clear, everybody? So Galileo is the scientist who demonstrated the relationship between what? Motion and as well as force. Okay. So he used two inclined smooth planes on which he rolled the ball to study the cause of motion. So that is what he has been taken. So you also can perform this activity in your home. So he fixed it two inclined surfaces, smooth and inclined surfaces. Be very careful. Smooth and inclined surfaces. He fixed it like this, and he started studying the properties of motion of the ball. So we all people also daily life, by this time you might be all experience at least once in your life. So you can see, if I drop the ball from this height, it will come this side also, it will go same height. If I drop the ball from here, from there it will start traveling, and again this side also it will reach us to the same height. Like that you might be all seen in our daily life, at least some one or two places when you are playing or some other place. Okay, so that is the same experiment done by Mr. Galileo to observe the study the cause of motion. So that is the experiment he has done. So first thing, what is the conclusions he has been made? What he demonstrated from this activity? What he observed? We all people also can try. It is there in our law. Observe, and every point we can notice it. First thing, the velocity of the body increases when it rolls down an inclined plane, and it decreases when the body rolls up to the plane. Am I right or wrong, everybody? So now the ball is dropped here, so that when it is coming to till here, velocity increases or velocity decreases, everybody?
Increases.
Velocity increases because it is coming down. Suppose you are traveling in a slope road, your automatically your velocity increases or decreases? Mr. Gokul Raj, Mr. Pranav? Increases. Clear? Now after that it is going up. It is going up like this. So when you are climbing a road which is inclined upwards, then your speed will decreases, or velocity decreases or increases, everybody?
Decreases.
Velocity
Decreases.
decreases. So that is the first thing Mr. Galileo noticed it. Clear, everybody? So the velocity of the body increases when it rolls down an inclined plane, and it decreases when the body rolls up the plane. So when the body is rolling up, decreases, coming down, decreases. So next, coming down increases, and going up, it will be decreasing. Clear, everyone? And with this point, all of you please
Yes,
respond. That is next.
Yes,
Second thing, if the ball rolls between two planes inclined equally, means what is the angle between them? Suppose if I draw here, mathematics, if I draw here, the angle between them is some x decrease, means here also how much decrease? Everybody, here also how much degree angle? With the x decrease. Clear, everybody? All of you? Please respond.
Yes,
that is what. So,
Yes, sir.
if the ball rolls between two planes inclined equally, it will attain the same height on both the sides. It will attain same height on both the heights. Have you all noticed it? The height from the body. Here I have dropped. Yes, Mr. Nivedan? The height which I have dropped here.
Sir, like a pendulum, sir, where it
Yes,
starts on the
Mali,
opposite
same height.
side.
So both the sides, it will attain the same height. That is what I'm saying. Clear, everyone? All of you understanding, Amma? Yes. If the inclined
Yes, sir.
equally, then both they will attain the same height in the both the sides. That is the second point. Everyone clear? Any doubt? Anybody can ask. Understand, Amma?
Yes, sir.
Yes.
Sir.
All of you.
Yes, sir.
All of you observe
Yes,
the
sir.
first plane, I fixed it. Now, second plane, the inclination is keep on decreasing. The inclination is keep on decreases. Then can you tell me, the ball will rolls over a large distance, or it will travel less distance? For example,
Large
this is the
distance,
same
sir.
inclination, but the second plane I made like this. Now you tell me, the body travel
Large distance, sir.
shorter distance.
Large distance.
Yes,
Large
please.
distance.
Yes.
Large distance.
Large distance. Am I right or wrong? Everybody, suppose if I drop the ball
Yes.
from here, it will travel like this, and it is not equal. See, if it is equal inclination, imagine this is the equal inclination. Then here also it will hide the same height. Yes or no? Everybody, Agalya, clear? But it is inclination is decreasing. Then what will happen? The body will travel more longer distance. Am I right or wrong? All of you understand, Ra?
Yes, sir.
Yes. For
Yes, sir.
example, I'll make the inclination more or less, almost C. Almost it is equals to plane. Then it will travel more distance or less distance? Fastly.
More
More
distance.
distance or less distance?
More distance.
More
More
distance.
distance.
I almost make it parallel. So then what will happen? Then the body will be continuously moving. Am I right or wrong? All of you?
Sir.
Yes, please.
Sir.
It will travel a long distance or not? All of you? Yes.
Yes, sir.
That is
Yes,
what
sir.
you should understand. So, if the inclination of the second plane is gradually decreasing, the inclination of the second plane is gradually decreasing, then the ball rolls over a large distance or short distance. Everybody, large distance. Understanding to attain the same height. Clear, Mr. Mari? Sanjay?
Yes, sir.
To attain the same height, it will travel a very long distance. Is it okay, guys? Please respond. All of you. Yes?
Yes, sir.
That is what.
Yes, sir.
Okay. So if the inclination is keep on decreases, then the body will travel a large distances to attain the same height from the initial, wherever you drop the body. So that is the thing which Mr. Galileo observed. Next, when the second plane is almost horizontal, that is what I said. The second plane is horizontal. Then what will happen? The ball continuously moving in a what? More indefinitely, but the second understanding, the ball will come to rest after traveling some distance. Actually, it has to be go continuously. But after traveling certain distance, it will come to rest due to the something. 8th class you studied. Due to the what?
Friction.
Due to the
Friction.
friction. Clear?
Friction.
That is what. Puremama, if the second plane is horizontal, the ball should go continuously in its motion, continuously move indefinitely, long distance, but it will come to rest due to the what? It will come to the rest due to the what?
Friction.
Friction.
Due to friction. Understanding? Now, for example, Mr. Kishore made this surface very, very rough. Second surface he made very, very rough surface. 8th class, LMA remembered a regular reflection, irregular reflection, physics.
Yes, sir.
Yeah. If he made the
Yes, sir.
surface rough, now you tell me the distance traveled by the body is more or less. When the surface of the second plane is
Less.
rough, the
Yes,
ball
sir.
would cover
Less.
less distance or more distance. Yes, all of you.
Yes, sir.
Rough means
Yes,
it will
sir.
travel less distance. Because of what? Roughness increases the friction or decreases the friction? Everybody.
Increases the friction.
Increases
Increases the
friction.
friction.
Very good. Understand all of you? So these are the facts. Mr. Galileo has been noticed from this small experiment. Simplest experiment, but makes a new era of physics. That is what Newton's laws of motion. The biggest concepts in the physics, present whole world is like many chapters in the physics in class 11th and class 12. Everywhere you can see, because of this small experiment, small idea of Galileo makes the Newtons to create a something biggest inventions, biggest things in the physics. So that is what Newton's laws. Okay. So based on this, all the facts, what is the first fact? Anybody can tell me? What is the first fact? I want to know. When the body falling down, velocity increases. And when the body rises, velocity
Decreases.
Decreases.
yeah, velocity
Decreases.
decreases. Next, if the ball rolls between the two planes, inclined equally, they both are inclined equally, then what will happen? Both
Equal
the sides
height.
will attain they will attain the same height on the both the sides and travel the same distance or unequal distance or same distance.
Same distance.
Same
They will
distance.
travel the same distance and they will attain the same height. If the second plane is inclination decreasing, the second plane is gradually decreased, then the body will travel more distance or less distance, everybody.
More distance.
To attain the what?
Equalize the height.
Yeah,
To
to
equalize
attain the same height. To attain the same height, it will travel a longer distance. Do you understand, everyone?
And in smooth surface, it will go more distance, sir, and in rough
Yes.
surface, it will go less
That is what.
distance.
For example, The second surface is very small. The second surface distance is very small. Then what will happen? After traveling, the ball will fall down. Am I right or wrong? Everybody? Clear? Understand everyone? Yes or
Yes,
no?
sir.
Yes.
Yes, sir.
Yes, sir.
Okay. So when the second surface is horizontal, almost horizontal, then body will travel what? The ball will continues to move indefinitely, but it will come to rest due to the what? It will come to rest due to that is what. So when the second surface is rough, then the ball will cover less distance or more distance. Everybody.
Less distance.
Less
The
distance.
ball will cover less distance. Very, very important. These are the 5 points. Based on this, all the facts, Mr. Galileo concluded that the natural state of the body is not the state of rest. The natural state of the body is not state of rest. It is the tendency of the body to oppose the change in its state of motion or change in state of rest. Do you all understand, everybody? Naturally, the state of body is not the state of rest. Do you all understand it? All of you? Mr. Galileo concluded that after all these facts, the natural state of the body is not the state of rest. It is the tendency of the body. Means it is a property of the body which will oppose the change in its state of motion or state of rest. That is the conclusion given by Mr. Galileo after this
Sir,
observation.
it is the tendency of the body then.
I will say it is a tendency of the body to oppose the change. Means the body which is in state of motion, it will be remains in motion. The body which is in state of rest, it is remains in rest. That is what? It is a tendency of them. It is not actually, it is the nature. It is a tendency. That is what Mr. Galileo concluded from this, all the facts. Totally how many facts, guys? Everybody? Totally how many facts? 5 facts. Okay. So all the 5 facts, everyone should learn, and everything you have to remember. Do you all able to remember or not? Everybody?
Yes, sir.
Yes. So very, very important. So once you learn this, all the 5 facts, then only Mr. Galileo made the statement. So let us discuss what is the statement made by the Galileo. So write the statement, everyone. You will understand now. Do you all understand what is the experiment conclusions, everybody? All of you?
Yes, sir.
Yes. So Kavya, you understand, Kavya?
Yes, sir.
Yeah. These are the 5 conclusions made by Mr. Galileo. Now, from this, what is the Galileo concluded from this? All the facts, 5 facts. All of you, read the statement. The natural state of body is not the state of rest. The natural state of a body is not state of rest. It is the tendency. It is the tendency of the body. It is the tendency of the body to oppose change in its state. Change in its state of motion or rest. So this is the Galileo's conclusion after all these 5 facts. Okay. Now from this only Mr. Newton formulated the laws of motion based upon the Galileo's experiment. Experiment is done by one and name is getting by some other. So that is what Mr. Galileo has been done everything, all the experiment, every facts, everything he has noticed it, and he has been passed away and something has happened. Then from his studies, Mr. Newton came up with the 3 laws. That is what we used to call as, what is that, everybody? Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Okay. So first, all of you write Newton's first law of motion. All of you keep reading. Newton's first law of motion, very, very important one. Again, 11th class, you will get the same chapter. Go and see 11th class, volume 1, chapter number 4. laws of motion. The same thing is going to happen. Clear, everybody? Gokul Raj, Mr. Lingesh, Pranav, that is what. So what is the first thing? Newton's
First law of
law
motion.
First law of motion.
Newton's first law of motion. Okay, all of you observe very carefully. What is Newton's first law of motion? So means we are having a two bodies now. So I will say one body which is in rest and one body is in uniform velocity in a straight line. Uniform, it is moving with a constant velocity or it is a uniform motion. Uniform motion in a what line, everybody? Uniform motion in a
Straight line.
motion
Straight
along
line.
a straight line. Now, this body is in state of rest. Now, what is Newton's first law of motion will says that, all of you observe, every body remains in state of rest. Every body remains in state of rest. Yes, Mr. Kishore, Galileo experiment discovered by Newton. Yes, truly. From the Galileo experiment only, Newton has been discovered these things. Okay. So, what is Newton's first law of motion? All of you observe very carefully. Suppose I am having a one body and I am having another body which is in uniform motion along a straight line. Now you tell me, I want to change the position of this body. What is the actual position of this body? Everybody speak. What is the actual position of the body? Rest.
Rest.
I want to make it into motion. I want to make it into what? Motion. Now, what is the actual position of this body? What is the actual body? Motion. Now, I want to bring it into rest. Now, if I want to make this body to motion or if I want to make this body to rest, I need to apply something. Can anybody tell me what
Force.
I need
Force.
external?
Force.
Am I right or wrong, everybody?
Yes, sir.
Yes, sir.
So that is what you should understand it. So that is only called as Newton's first law of motion. Unless and until a body experience are compelled by an external force, the body which is in state of rest remains in state of rest. The body which is in uniform motion in a straight line will remains in uniform motion unless they compelled by an what, guys? Unless they compelled by an
Force.
force. Unless they compelled by an everybody.
Sir, one doubt, sir.
Yes,
Sir, an object in uniform motion will be stopped due to friction, no, sir.
that frictional force is external force. Do you understand, Mr. Mari? If I create a frictionless surface, now tell me, what will happen? If I create a frictionless surface, then what will happen? The body will never come to
Endless,
rest.
sir.
Do you understand?
Endless.
So the
Yes.
frictional force is a what force actually, guys? The body which is in uniform motion is coming to rest because of what force, everybody? Due to the what force?
Frictional force.
So friction is the what actually? Friction is the external force. Do you all understand, all of you? Clear, everybody? Yes, please. Pranav, that is only called as Newton's first law. Newton's first law will says that. All of you observe very carefully. What is Newton's first law? Every body remains in a state of rest or of uniform motion along a straight line unless and until it is compelled by an what force, everybody? Unless and until it is compelled by an
External force.
clear? That is what. Now, for example, you are having a one table in your book. Suppose in front of you now, you are all attending the class from the laptop or desktop, whatever. You are having a table. There is a book you kept, physics book. So this is a physics book. You kept it. Now it is in a state of what, everybody? It is in a state of rest.
Rest.
Now, if you want to make it move, then suppose today you kept, tomorrow you kept, day after tomorrow you kept. After 10 years also, if it is nothing damaged, you can see the book will be remains in state of rest only. Am I right or wrong? Because if it wants to move means it needs to experience by an external force. What? Our hand should hold the book and we have to apply the force from our body so that we can make the physics books to move forward. Am I right or wrong, everybody? Yes or no? Yes.
Yes, sir.
Unless an external force is applied, the physics book will never move from the bench. Am I right or wrong, everybody?
sir.
Yes, that is what. So that is only called as Newton's first law of motion. So please write it. Newton's first law of motion. How many of you understand? Everybody clear?
Yes, sir.
Yeah.
Yes,
Any
sir.
doubt in this class? Both Hasinis, Purima, Sudarshan. Okay. So please write. Mr. Sam, okay. Mr. Gokul Raj. Okay, proceed. Completed? Let me know. Then we'll continue. So from the Newton's first law, we'll understand two conclusions. Can you tell me what is the first conclusion you can make? From the Newton's first law, we can make first conclusion. So you can make Newton's first law of motion help us to understand two things. Anybody can tell me what is the first thing you understand from the Newton's first law? First thing, an external agent only called as, day before yesterday we studied, called as balanced or unbalanced? Everybody.
Unbalanced.
Unbalanced
Unbalanced.
external force. Remember, Agalya, Alpin,
Yes, sir.
unbalanced external force only makes the body to what? Makes
Move.
body, yes, makes the body to move or makes the body to stop. Yes or no? Everybody? Yes?
Yes.
That is.
Yes, sir.
So that is the first conclusion, right? An external agent or an unbalanced external force, an external agent, that is the first conclusion we can understand from the Newton's first law. An external agent or an unbalanced external force, is required to accelerate a body. That is the first thing. Next, second, one more conclusion you can make it. Anybody can tell? If there is no external force, then what will happen? All of you.
Sir, it will be in movement or in rest.
Yes,
There
and
will be
they will
changes
continue
in-
their state of motion or continues their state of rest. Am I right or wrong? All of you?
Yes, sir.
Write it. A body cannot change its state. A body cannot change. A body cannot change its state of rest or of uniform motion. Uniform motion along a what line? Everybody.
Straight
Uniform
line.
motion along a straight line. On its own. So they cannot come its own unless they cannot be experienced by what? Unless they cannot be experienced by a external force. Clear? So by their own they cannot. Is it physics book will move its own from here to here? No. You understand, Amma? So whenever it is, today or tomorrow, day after tomorrow, after 1 year, after 10 years, you must apply the what? You must apply the external force to move the physics book. So by their own they cannot come. They cannot come into rest, which is in uniform motion. They cannot become a motion, which is in state of rest. So they need always external force. That is the conclusions you should understand from Newton's first law. Everybody clear? All of you?
Yes, sir.
Yes. So now, from this Newton's first law, it will give us a very precise and important definition, which is called as inertia. So this is the most important one. Tomorrow we will study types of inertia. That is what? Inertia of rest, inertia of motion, inertia of direction, mass and inertia. Like this, many things we'll study. And then only we'll go to the Newton's second law of motion. So Newton's first law will gives us the precise definition of inertia. That is why Newton's first law also we can call as Law of inertia. What is to call everybody? Law
Law
of
of inertia.
Okay.
Inertia.
So let us understand what is law of, what is inertia. Okay. So let me take for example, I will consider one bulky boy. Let me take a bulky man who is actually like 100 kg. Okay. Now he is standing. He's in a state of what now? A bulky man who is in a state of rest. Who is in state of what? Everybody? He's in state of rest. Okay. Now he wants to be in rest. What is the actual position of him, everybody? What is the actual position of him? He wants to be in rest. Clear?
Yes.
Now I'll ask Mr. Lingesh to push him, make him to bring it into motion. So is it possible to make him motion by Mr. Lingesh? Mr. Lingesh?
No, sir.
No.
No,
Clear?
sir.
Why? Because he don't want to change its position. He likes to be stay in what actually? Rest. And but Mr. Lingesh wants to make him to motion. So Lingesh failed to make him motion. Why, guys? Anybody can tell? Because his resistance force is greater. Am I right or wrong? Resistance force is more than the force of Lingesh, so that he is not able to move. Because he wants to be in state of rest. Now Lingesh joined with the Kishore. Kishore joined with the Nivedan. Nivedan joined with Mr. Mari. Now Mr. Mari joined with Mr. Sanjay. Mr. Sanjay joined with Darshan. Now all the people are trying to push this bulky man. Then what will happen? This man
Resistance force breaks.
resistance to the leg. His resistance cannot be. He cannot make it because we are applying the greater force than his resistance. That is why the man will start moving from rest into motion. Am I right or wrong, everybody? Do you all understand, everybody? All of you? Yes, please respond.
Yes, sir.
Now,
Yes,
opposite case.
Sir.
Let me take, there is a car, very big car. Let me take now. So this is a famous car, which is resistance means opposing Lakshanya, opposing. I don't want to change. Suppose somebody is pushing you, you will stand and you will say, you cannot move forward and backward. Have you remember that is called as resistance, opposing. Clear? That is now a car is moving with 100 km/h. How many km/h? Everybody? 100 km/h. Clear? Okay. So let me take, this is a Innova car. Very fastly it is traveling. So now I will ask Mr. Mari to stop this car. Now tell me, is it Mr. Mari force is sufficient to stop this car?
No, sir. No,
No,
sir.
sir.
Because this car wants to be in what? This car wants to be in what? It wants to be in
Motion.
motion. So Mr. Mari will start applying the force. Mari become 2, 3 become 4, 4 become 5, 5 become 6, 6 become 7, 7 become 8. Like that, many people join together. Then they can stop the car or not? All of you? Yes? Yes, they can stop. How? By the time the applying force by them is greater than the opposing force of the car, so that the car will come to rest. Do you all understand it? Yes. Suppose 9 people are there. Still 9 people cannot able to stop this car. As soon as the 10th boy will join, then the car will stop. So till 9 people, why they fail to stop? Because the car force is greater than them. Am I right or wrong? All of you?
Yes, sir.
That is. Now, instead of Innova car, I will put a Audi car. Sorry, I will put a Ambassador car. Now you tell me, Ambassador car, it is easy to stop or difficult to stop compared to Innova car? Easy to stop. Same way, instead of Mr. Bulky or a small Kutti Baya is there. Now you tell me, is it we can make him easily move or not? A small baby.
Yes,
Yes or no? Why? What is the
Yes,
difference
sir.
between the bulky man and the small man?
Sir, he has a large
Yes,
resistance, but the child doesn't have
That is
resistance.
what we used to call as mass. What is to call, Mari? Mass
Mass.
difference. Clear? That is the reason. So the mass of the body is greater, then the opposing force is higher. Am I right or wrong? Yes.
Yes, sir.
Okay. So the Abhirami is asking something. So then the force of sudden brake is greater than the force of a car. Yes, Abhirami, the brake force is more than the car. That is why it will changes its position. Okay. So that is only called as inertia. So I hope you all understand now. You see that the tendency of a body remains in state of rest or of uniform motion along a straight line is called inertia. They wants to be the tendency. Yes, my wish, I am a car. I want to be in motion. I want to be in a motion. I want to be in a motion. But it will depends on my capacity. Am I right or wrong, everybody? And I am a man, bulky man. I want to be in state of rest. Nobody can change my position because I like to be in a state of rest. That tendency is called as inertia. What is to call everybody? It's called as inertia. Clear, everyone? Now, due to inertia, an